Good morning, good afternoon, everyone. Welcome and thank you for joining us for this GridOS DERMS webinar. My name is Delphine Hafner. I will be the moderator for this session. Today we have two great speakers with us. Our first presenter is Jasjit Singh. He is our principal architect to solution DER related problems. Jasjit has more than 18 years of experience across global markets. He worked with major consulting firms. He worked with startups. He has published multiple white papers. Jasjit is passionate about clean energy future. He is helping the GE Vernova customers to drive net zero energy solution roadmap for their end consumers. And he was also recognized as a flagship example of global talent in energy sector by the Australian government. The second speaker is Ronnie Shako, who is our principal solution architect specialized in distribution and transmission OT solutions. Ronnie has more than 14 years of experience in power grid software business, and he is a technical trusted advisor to the customers in the Asia Pacific region, where he is actively helping our customers to achieve clean energy. Outside work, Ronnie is also a triathlete, and he participates in Ironman championships, so he can also talk sports with you. This is the agenda for today's session. We have 1 hour together. We will start by discussing some of the key DSO challenges that we see in Australia, in New Zealand, in Asia, and also globally. We will review what is the role of a DSO and DNSPs in terms of future networks and how do they collaborate. We will talk about what we see in the markets, what are the trends. We'll present some of our AI ML-based use case. And then we are very excited to present how GE Vernova can help the future DSO transition with some of our new products and DERMS capabilities. We will conclude the presentation with 4 case studies, 2 from Australia, 1 from Singapore, and 1 from the US. We will allow for a Q&A at the end of the session, where you can feel free to type your questions in the chat, ask us anything you want. We will try to address your questions. And if we can't answer all your questions today, we will follow up with you by email. With that, without further ado, I will hand over to Jasjit. Over to you, Jasjit. Thank you.
Good day, everyone. I'm Jasjit, and thank you, Delphine, for the wonderful introduction and kicking off with the agenda. We will be talking about some of the key challenges for the future DSO transition. So let me begin with by simply talking about the need for the future DSO transition. First of all, as we know, all the major countries and economies, they have signed up for the net zero and the climate change goals, and everyone is working towards achieving a net zero or the real zero as well. And in order to achieve those ambitious goals, the major driver or the major enabler is the network or the grid network. And the grid network has to enable the clean energy transition and ultimately help everyone to achieve the climate change goals. And in terms of the network itself, there are a lot of challenges that's coming up and which can be addressed by some of the DSO capabilities. And we got some of those challenges listed over here to begin with. As you can see, the 3 or 4 major different categories. The first one on the top, on the left-hand side, is network capacity utilization challenge. We all understand across all the major economies and across the globe, the networks are always built based on the peak demand. However, the utilization of the network capacity is not always optimal. As a matter of fact, there was a study conducted by LEK Consulting in the Australian markets recently, and they figured out there's a huge underutilized capacity that already exists, and that can be utilized for effective integration of clean energy resources, which ultimately drives the overall clean energy goals, and the overall climate change. Similarly, there are other challenges on the network as we are built today, and it's been probably more than 100 years the network has been operating the way it has been doing in the past, but there is not enough flexibility that's being embedded into the network. Now we understand flexibility is probably a silver bullet when we talk about future DSO transition. Of course, it's not a one thing. There are multiple things, there are multiple ways how to create a flexibility, how to access flexibility, and how to commercialize flexibility. But this is the one thing that can actually help a lot to achieve the overall future DSO transition. In addition to some of those network capacity utilization challenges, we also understand there are new ways of power flow. Now we see two-way power flow happening, which is causing all sorts of voltage issues and the protection relay issues when the reverse power flow happens all the way up to the transmission networks as well. And the intermittency of the CERs or the DERs itself, it's a huge risk because the sun is not always shining and the wind is not always blowing. And it becomes really difficult to manage and host the variable resources of energy effectively on the grid network that has not been designed for such difficult behaviors, and there's not enough flexibility already that exists on the network. In addition to that, some of the places we see now challenges like in Australia, minimum demand, and we are already helping and working with our customers to solve some of those interesting challenges. But the minimum demand challenges where we see a huge PV generation on certain days, and there's not a peak demand expected on those days, which caused to almost a zero demand on the network across different states of Australia. So all of these challenges are contributing and making the requirements coming towards that why we should be shifting towards building a zero regret or low regret DSO capabilities. And also on the regulation side, we can see on the right-hand side, there are new regulations and rule changes that's coming up very frequent and very often now, all in the spirit to support the clean energy transition. So we had two-sided markets, which was coming up in Australian market. There are mandatory emergency backstop measures that's being conducted and already happening in the local markets. And also very recently, energy ministers have released a national CER roadmap, which is going to enable and unlock the opportunities from the energy resources, which is behind the meter, as well as also looking into what are the possibilities and opportunities we can create in terms of saving potentials for the customers. And then finally, we have new stakeholders onto the grid network. Maybe 10 years ago, we did not have a huge presence of VPPs or aggregators or distribution market operators. But with the coming up of the new stakeholders, there are new ways and mechanisms that are required so we can completely shift to the zero energy transition goal, but also do it at a cost-effective manner. So putting together all these challenges are enough in terms of saying why there is a need and why across the globe, all the network operators, they're making efforts to shift to the future DSO transition. So I'll quickly talk about what is the role of the network operators and the distribution system operator. It's not that the role of distribution network service provider are going to vanish somewhere in the future. That is a key role. It will continue to happen in the markets. However, there are additional capabilities that are required in the markets so we can enable the overall effective energy transition. And we can see on the left-hand side, there are the traditional roles and responsibilities listed for DNSPs or the network operators, which is about building a future adaptable, flexible network. So of course, there are some bit of added responsibilities where you need to build the network, but simply not building the network with poles and wires, but also understand how we can embed flexibility right from the connection agreements, whether this is a small customer, whether this is a large customer or a solar or wind farms, how we can have the flexibility embedded into the new connections. And also to provide the accurate and reliable data on the network model, assets, and the loading, so the DSO can make effective decisions when we talk about the flexibility. And they will continue to manage the asset health and the performance, because the assets are also growing. A lot of assets are probably beyond 50 years of useful age, and hence it's important to manage the health of the performance of the assets as well, as we see a large penetration of DERs and CERs coming up on the network. And of course, there is the underlying goal, which is to keep the lights on, and it's not going away. Now, how DSOs can actually help in this overall ultimate goal, and we can see there are additional capabilities. For instance, the DSO's role would be to accurately size the new capacity required to serve the current and the future needs. Now, DSO will probably think beyond the traditional network planning aspects, and they will look into the flexibility aspects and look into the multiple scenarios that are likely to happen, and also identify where to have the flexibility, how much flexibility is required in the future, and how best to utilize that flexibility. And DSOs will also help to make decisions in terms of not just creating a flexible capacity, but also to figure out how best to use it for non-network solutions or the non-wire alternatives, which is the biggest cost driver, and the shift from poles and wires business to the platform business, which we usually call it as Uberization of the grid. And they will look into the DSOs will also look into the procurement of flexibility from the marketplace if required, and also make some decisions, the smart decisions, that how best we can dispatch flexibility to respond to the variety of the grid events or the network constraints or any other issues that's coming up because of the penetration of CERs and the DERs. So this is not a prescriptive list. So this is what we see are already happening in UK markets and European markets. Of course, there's no defined model as of now, which clearly outlines the roles and responsibilities. There could be a same organization where you can have a DNSP roles as well as another business unit, which looks into the DSO aspect, or there could be two different entities as well. The one case in point example is the UKPN. So they've got now a DSO entity rolled up, and then there's another DNSP as well, which is operating in the market. So I think this is more like the wait and watch, and we see how the market will evolve. But there are certain capabilities that would be there and would be required for sure as we transition to the more high penetration of CERs and the DERs. Now with that, I will quickly talk about some of the high value use cases. And when we talk about the high value use cases, those use cases can be enabled using the latest AI and machine learning technologies. And they are very compelling use cases, especially in those markets where we see the penetration of DERs is going beyond 50%, 60%. In some areas, it's beyond 70 or 75% as well. Now, what are those use cases and why those use cases are required? I would again refer to one of the recent reports done in the Australian markets along with the ENA and LEK. And as per their report, there are about $7 billion of annual benefits to the consumers by 2030 if we are able to enable and orchestrate the CERs and DERs effectively under the all levers pulled scenario. So there are different assumptions how to enable and unlock those benefits, but then there are certain use cases and capabilities which contributes to those benefits as well. So the first one over here, which is a AI-based optimal management of the zero demand use case in national electricity market and Western electricity market, which is quite specific to Australian context. However, this is still happening in the different parts of the world, and probably is going to happen in a different time periods as well, maybe 6 months or 2 years down the line. But definitely as the DERs and CERs will continue to grow, the obvious challenge of managing a low demand or zero demand is quite inevitable. And with the use of AI and machine learning scenarios or the capabilities, you can accurately predict when the minimum demand is likely to happen, and how exactly we can jump into the market and orchestrate CERs in terms of whether to curtail or whether to charge batteries or EVs, so we can effectively manage those scenarios. Similarly, there are 3 or 4 more use case scenarios. I won't get into a lot of details, but happy to have a detailed discussion on these use cases, which is about running millions of scenarios for flexible networks, where you can run in every 5 minutes multiple scenarios and figure out how the future network is going to look like. And then also to real-time orchestrate behind the meter resources, as well as the grid connected batteries or community batteries coming all together to solve multi-objective functions for whole of the system optimization. Similarly, there is a use case on predicting the shortfall in the system strength and the inertia, but also to have advanced capabilities to do the autonomous procurement if there is a shortfall of the system inertia or the system strength or the inertia. And finally, there's the application of AI machine learning to reduce the grid interconnections time, which typically spans from 18 months or 24 months, and significantly those times can be reduced by introducing the RPA and AI machine learning technologies. So the next topic is we talk about DSO transition. We understand the challenges, and we really understand the importance of the DSO aspects. Now, how GE Vernova can help you with your DSO transition journey? From GE Vernova perspective, we have 3 major capabilities across the different pillars. So you can see on the slide, the first is the planning aspects. The second is the operational aspect. The third one is the transactional aspect. Now, when we talk about DSO and we talk about the flexibility, it cannot be seen from just one perspective. It has to be seen right from the planning aspects, that how do we understand about the flexibility requirements, how much we are willing to spend, at what time, at what location, for how long, to do what. And then also we need to operationalize the flexibility that is being embedded within our networks. And finally, how we can transact the flexibility in the open markets. And you can see there are different applications under these major pillars. Within the planning aspect, we offer 2 applications, which is a simulation application and forecasting application. The simulation helps you to understand the scenarios, which could be a week down the road, or could be 3 months, or could be 3 years, and you can go up to 20, 25 years as well, where you can create your own scenarios and do the what if analysis. What if the batteries will grow to this percentage? What if the EVs will continue to grow at this percentage? What if everyone has a rooftop PV panels, 10 kilowatt of size, with a firm connection or with a flexible connection? What happens to my network? So you can run those scenarios and you can understand the upcoming challenges on the network. So how the network constraints are likely to come up, for what reasons, at what locations. And the forecasting is a key input when we run the simulation scenarios, but also helps us to understand that how much flexibility we need in the future, and how we can forecast the true load and the net load when we talk about the real-time scenarios. Similarly, in the operational aspect, we enable flexibility by having a gateway module. The gateway module is our arms and legs of the DERMS, which can connect with the resources using the industry standards. So we follow CCPOS 2030.5, as well as the OpenADR and the other standards. So we can communicate effectively with those CERs and DERs so as to control them as and when required. And then operations and optimization modules work together to provide situational intelligence. What is happening in my network in the real time? What are the DERs are doing? Are they actually performing or behaving as per the expected behaviors? Are they really in the compliance? If there are flexible connections, are they really flexibly exporting, or they're firm connections, but they're not exporting more than the expired, more than the approved limits? So everything can be seen in the real time using the operations module. And the optimization module helps you to figure out the best ways, the cost-effective ways to resolve the network constraints by understanding how much flexibility you have and how best to dispatch those flexible resources to resolve voltage issues or thermal issues, or even provide services back to the market operator. And finally, on the right-hand side, we got two modules, which is a program manager, which basically helps you to figure out what are the different programs or flexibility products that you would require in the future, how to create and design those products, how to engage with the customers, and how to have a social license agreed in terms of getting those CERs and DERs into the system. And then the market orchestration module can help to orchestrate those resources and also get connected with the markets, flexibility markets, as we see like in UK, they're already operating, and how to work closely to publish network issues, constraints, signposting of the requirements, and get those flexibility requirements in the procurement in real time when we need to solve the network issues. And this is all built on the GridOS platform, which is a zero trust security platform. It has a unified UI UX across all the applications. And this is enabled by the Grid Data Fabric, which is a purpose-built data platform to enable the utilities analytic use cases. Now, there's a quick reference workflow in terms of how the things are happening now and how the things are likely to happen in the future DSO scenario. It's a very high-level scenario. It does not have a lot of details at this stage, but every single step of the scenario have multiple use cases and further sub-scenarios, and we are happy to have that discussion. But at a high level, the first one is a scenario planning. So scenario planning is required for the DSOs as of now and in the future as well, where you can create multiple scenarios to figure out how the future network is going to look like. Where are my vehicles are coming? Where are the fast charging stations are coming? Where are the community batteries are coming? Where are the grid connected batteries are coming? You can have all those scenarios and you can predict the growth of those CERs or DERs and then run the power flow to figure out how my network is going to behave. And within this module, you can always leverage the outputs and have a discussion with the regulators and say, this is what we believe is going to happen. And these are the living scenarios. It's not one-off, written in a document and never been improvised. So they're always a living scenario, very close to the actual anticipations that are likely to happen. And they can help you to get the investments and have a discussion how best to build the network and how best to have the flexibility embedded in the network as well. The second aspect is that now you know what's going to happen. You've got the scenarios already built. We also need to understand what's the real-time situational awareness or intelligence on the network. What is right now going on? Do I have a constraints on my network? Do I have any voltage or thermal issues on the different parts of the network? Can I not meet the peak demand in certain network in certain times of the year? So all those scenarios of peak demand or network constraints is covered in the real-time situational awareness, and that leads to the assessing the flexibility options. Now, since that you're already thinking about flexibility in the first place, which means you got dynamic connections or flexible connections and the access to the CERs and DERs, so the assessing of the flexibility becomes easier, and you can always look into what are the active and flexible DERs and CERs available in the real time to resolve whatever the issue is happening on my network. And then with the help of the automated smart dispatching algorithms, they can either autonomously dispatch those CERs and DERs to resolve the issues, or the operator can always look into the dispatching algorithm and see what are the actions proposed, and it can approve that, yes, this sounds good, and hence the dispatch will happen. If there is not enough flexibility embedded already into the networks, so if you need 100 megawatts of flexibility to resolve issues as we speak today, however, I don't have that enough capacity, so I can always go to the DER marketplace and say, I want to procure extra flexibility from the market operators, from the flexibility providers or FSPs. And once we engage them to resolve the same issues, finally there is a tracking of performance and the settlements that happen. Now, it's just a high-level perspective, but there are different ways and mechanisms, and there could be additional steps involved depending on the different situation as well. Now, just taking some examples of the use cases are agnostic of systems, no matter what system or what applications are there. We talked about simulation already, but just to quick take one more example. So when you do a what if scenario management, you can see there's a very interactive UI where you can see uh, the feeders with the color coded hosting capacities. When you run the different scenarios, they will turn amber or green or red, which indicates that these are the predictive issues or the constraints in the network. And hence, the decisions can be made whether we need to update the network or we need to include the flexibility. And in specific aspects of Australian markets, AER has introduced some measures as well, like customer exports, curtailment value, and the network capacity allocation methods. And that all can be enabled using the simulation application and say, this is the outcome, and these are the measures which can inform how much we need to invest into the network and what is the level of flexibility that we need to have. Similarly, there's another use case of automated constraint management. We talked about constraints before, but what if you can automate all the constraints? So there's no need to look into every single constraints that's coming up on the network, and somebody has to actually manually go and dispatch the DERs or the CERs every time there are constraints on certain feeders or certain zone substations or certain specific locations of the network. With the automated constraints management capability, you can automate the entire process, or you can do the semi-automation as well. And there can be operator again before the dispatching happens. But the automated constraints management brings together a workflow which works with the different applications and modules to understand what is happening in the real time, what happens, and you can have a predefined triggers. What happens if there is a minimum demand unexpectedly coming up on the network? So whenever that happens, look into the active DERs and active PV panels who are generating, and they are the flexible connections, how much we can curtail, and we can get the minimum demand or the demand back on the network. Do I have a batteries as well where the state of charge is below 50%, so I can charge those batteries or EVs? So you can have those predefined rules and triggers, and ACM will consistently in the real time will keep looking for any of the issues that happen, which is a trigger, and then look into the options, the best options, which can be dispatched to resolve those issues. And it can be done in the different phases. So you can have a semi-automatic and the fully automated, and the operators approval required as well before doing the automated constraints management. Highly useful when there are more number of DERs and CERs coming up into your network and you have unpredicted constraints coming up more often. So in that case, this is very useful capability. And there's another use case on the optimization. Again, I've talked a little bit about the optimization before, but in terms of giving the power to the users itself, now, and as an end user, you can define your own objective functions without depending on the heavily mathematics ability to figure out what are the quadratic equations, how do I write up optimization equations. I don't need to work with the solvers to configure my optimization function, but within the UI, you can create the optimization functions, and you can say, I want to maximize or minimize certain exports or imports from these DERs or interconnections, or I want to dispatch the batteries when this happens. And those rules are fed back into the solver, and the solver works for you to resolve those objective functions. And you can create more than one optimization and objective functions with the optimization module, and you can run those optimization functions based on certain triggers as well. Similarly, there's another one in terms of enabling flexibility markets. Again, we're talking a lot about flexibility, but how we can actually enable flexibility markets. So with the program manager module within the GridOS DERMS, we offer a productized integrations with the leading providers of market platform providers, where you can create a request within the program manager, and you can say, I'm looking for about 50 megawatts of flexibility for raising the demand or minimizing the demand, or in terms of ancillary services or whatever is the requirement, and then publish it via the market providers. And then the market providers can publish to all the aggregators and VPPs and FSPs, and then they can start responding to your requirements as a competitions, and then they can provide the bids, and you can get it back via the market platform partners into the program manager. So there's a single window where you can manage all your flexibility aspects, contracts, how much is required, what cost you are willing to pay, and how best to leverage the flexibility from the markets to respond to various grid conditions. And there's another one which is quite prevalent, again, in the Australian, New Zealand markets, which is the dynamic operating envelopes. We do enable DOEs by running the power flow on the network, and we do help DNSPs to maximize the hosting capacities by running the DOEs and figuring out how much we need to curtail, what are the safe operating limits for PV panels or batteries or any other CERs at an NIMI level, and how best we can orchestrate those resources within the limits of DOEs as well, so we can maximize the asset utilization. And we also enable something which is quite important as an equitable access to the network. So you can have a different ways and mechanisms, how you can configure and how you can allocate the network capacities based on the DOEs. But the most important part is that the DOEs calculated are also informed of the network topology changes. So they're not necessarily acting as a model-free DOEs, but they're acting more as grid-informed DOEs. If a switching happens, or the topology changes, or any unplanned outages happens, or the feeders are being switched for the load balancing or for any other objective function, the DOEs would be aware of what's happening on the other side of the network, and hence they're being recalculated to accurately reflect the network constraints on the network. So there are multiple use cases that can be enabled with the GridOS DERMS. So these are some of the references that I talked about, and more than happy to have a discussion in terms of what are the other use cases, what are the other scenarios, and what are the other AI and machine learning capabilities that we can bring along and help you in the future DSO transition journey. Now, the last one is that how we now deploy the flexibility. So we talked about flexibility, we talked about the capabilities and use cases, but what are the different ways and mechanisms that how we can implement the flexibility into our systems, into the, as we speak, in terms of whether we have existing systems already, or we are planning to have more systems or the advanced systems, how this will work with our systems. So there are three different ways. One is that you have a GE landscape already. So we work seamlessly with the GE systems, and there's a seamless integrations between the different applications on the DERMS and the ADMS side. However, if you have a different network management systems or network advanced distribution management system, we can still work with the ADMS of your choice or the existing one and enable the flexibility by having the defined integrations that we need to work with the ADMS side, as well as on the market side. And finally, on the DNO and the DSO aggregation that we've been talking about, we can enable the capabilities on DNO and the DSO as well, whether that exists in the same organization or in the different organizations. It can be enabled in the both ways. The DSOs would have some additional capabilities in terms of connecting with the wholesale and flexibility markets and working it backwards with the simulation module to assess the future scenarios. Now, can I really resolve the expected or the predicted constraints if I get enough flexibility from the markets? So all those additional capabilities come along when we talk about the DSO side of things. And you can have, whether this is on the cloud or private cloud or on the hybrid cloud or on premise, we enable all of those capabilities and help you with the future DSO transition journey.
We are now in the Q&A session, and I can see we've got quite a few questions in the chat already. So maybe let me start with the first one. Will the simulation consider normal network state or real-time switching as well? Jasjit, do you want to take this one?
Sure, Delphine. So yeah, that's a good question. The simulation module is built from the purpose of flexible future networks planning aspect. Now, in specifically when we are running the simulation module to do what if scenarios, it's considering the normal state of the network. However, when we have an operations module that actually considers the real-time switching and what's going on in terms of topology changes or any unplanned outages, but that's a different module. So simulation will consider the normal state network and the future expected growth state of the network.
Thank you, Jasjit. Next question is, any consideration on local regulations and rules?
Yep, happy to take that one up as well. Yeah, we do consider the local considerations and the rules. So I'll take some examples. The first one that my colleague Roni talked about is the emergency backstop. It's a Victorian and Australian specific, a local regulation, and we are always working with our customers and partners to implement the required rules and comply with the regulations and policies as well. And hence, we made always a lot of changes and tweak the product and capabilities so we can help to align with the local market challenges. So emergency backstop is one, but we also look into the supporting the CCP Australia specific communications, while industry standard is IEEE 2030.5, but the GE's gateway module actually complies with 2030.5 Australian version, which is again specific to the local market requirements. And then also we also look into the AER's upcoming rules and regulations in terms of I talked about customer export, curtailment value, and the network capacity allocation rules. So we look into those aspects consistently, and we always make the tweaks and changes in the roadmap to align with those requirements and the regulations. So yes, so there are quite a few examples, and we always look forward to continue to work with the local market compliant regulations and the rules.
Thank you, Jasjit. I'll select another question. Let me try to push it here. Okay, so I think everyone can see the question on the screen now. Do we need full AMI implementation, distribution, automation, and DER telemetry data to run all these key DSO functions, or there is an alternative path?
Yeah, that's a very good question. I can take a first stab on it. We do need AMI data for multiple use cases. I probably would not say we need a full AMI implementation. We can work with the minimum data that's available, and the different modules would leverage AMI data and implementation. For example, forecasting a module can depend on some of the smart meters data to improve on the accuracy, especially when we talk about the NIMI level, the National Metering Identifier, which is the meter level in Australia. So we would depend on the data that's coming in from smart meters, as well as for some of the LV visibility use cases. Yes, we would need that data, but we are not constrained by having a full 100% accurate data in the first place, and then we can begin with those modules. We can start small, and we can continue to have more data as we progress, and hence those functions and capabilities can be improved when we have more data. Similarly, on distribution automation and DER telemetry, for operations module, where we enable the situational awareness, yes, we do need a DER telemetry data, and it depends on getting the real-time data back from batteries, EVs, or PV panels and the network side as well, so we can provide a real-time understanding what's going on, where are the constraints, and how best we can resolve the constraints, including the behavior of the DERs. But that data is coming itself from the DERMS gateway module. So we get this data directly via the CCPOS, and we leverage the data that's coming in the gateway to provide that information. But yes, there's a huge dependency on the data. But the way the modules have been designed is to start small, because no one has the full 100% data as we speak and as of today. So we can start small and then we can expand as we have more and more data coming from these resources.
Okay, thanks, Jasjit. I'll try to select another question. Can we choose individual components from this suite of functionalities? Can I implement them without going to GridOS architecture now?
Yeah, that's another good question. Happy to take a first stab. So the short answer is yes. You can actually choose individual components and applications. So I covered about 7 different applications which we provide part of the GridOS DERMS, which is forecasting, operations, simulation, optimization, model manager, program manager, market orchestration. Every single application is modular and you can start with it. So again, my colleague Ronnie talked about Energy Queensland example. They picked up just a gateway module because that was the main need and the driver at that stage. Similarly, there are other examples across different global utilities who have picked up 2 modules or 5 modules. Some customers like Osnet, they have picked up the entire stack. It completely depends on the requirements and the business goals and the strategy and the roadmap of a given network operator. But we do enable a modular implementation of these modules. And all the DERMS modules are already built on the GridOS architecture. So there is no wait in terms of going to the GridOS architecture. The whole stack of DERMS is already available on the GridOS platform.
Thank you, Jasjit. I think we are almost at the top of the hour, so I will select the last question for today. And for the question that we could not answer today, we will follow up with you by email. But let me just select the last question for today. Is there a SaaS model of deployment option available?
Yes, it is, and I think I might have missed in my slide where we talked about the deployment flexibility. But yes, we do offer the complete DERM stack, which is on the GE-hosted cloud and as a SaaS model as well. It completely depends on the choice of the network operators, and we can enable that choice.
Okay, thank you, Jasjit. I think we will wrap up here. And I saw that some people asked in the chat if we could receive some documentation from us. And yes, we will follow up with you, and we'll definitely share some material after that presentation. But also, if you want more details, you can reach out to your GEV sales account manager, and we will be more than happy to arrange a follow-up session with you, an individual session with you to spend more time on your particular use case if you want to. And in addition, if you have any suggestion or if there are things that you would like to see in future webinars, please don't hesitate to contact us as well. With that, we will wrap up. And thank you so much, everyone, for joining us today. We were very pleased to see all of you, and we really hope that this webinar was useful to you. And have a good day, everybody. Thank you. Bye for now.
Thank you, everyone.
Thank you, everyone.